Welcome to Algebra 1. The learning goal for this episode is to learn the definition of scientific notation and how to read and write numbers in scientific notation. We often need to work with either very large numbers, think astronomy, or very small numbers, think molecules and atoms, where we are more concerned with the order of magnitude of the number than we are with getting the number exactly right. We often use scientific notation to help us with these types of numbers. A number is written in scientific notation when it is in the form c times 10 to the n, where c is between 1 and 10, and n is an integer. So, for example, instead of writing 5 million as a 5 and then 6 zeros, we can write it as 5 times 10 to the 6th. The same idea with 8 10,000ths. We can write it as 8 times 10 to the negative 4. Let's look at some examples. We want to write 98,231,000 in scientific notation. We need a number between 1 and 10, so we place the decimal between the 9 and the 8. So that gives us 9.8231. But now we need the power of 10 that will make this equivalent to 98,231,000. To figure that out, we simply count the number of places we move the decimal point from its original spot. Alternatively, if we know our place values, we simply look at the place value of the order of magnitude, and that tells us the power of 10. Using either of these methods for this problem, we get 7. Either we move the decimal 7 places from where it is currently, after that last zero, to get it between the 9 and the 8, or we think about the 10 millionths place being 10 to the 7th. So, in scientific notation, we would write this as 9.8231 times 10 to the 7th. It is important to realize that this is equivalent to 98,231,000, just a different way of writing it. Here's another example, this one a very, very small number. This time we place the decimal point between the 6 and the 4 to get 6.42, a number that is between 1 and 10. In order to do that, however, we had to move the decimal 6 places to the right, so our exponent is negative 6 because we're dividing by a power of 10. Or we can think of the 10 being in the millionths place, so 10 to the negative 6th power. Therefore, in scientific notation, 6.42 times 10 to the negative 6 is equivalent to 0.0000642. Sometimes we need to take numbers written in scientific notation and perform operations on them. In this case, multiplication. The easiest way to do that is to multiply the c part separately and the powers of 10 part separately. In this case, that means we'll multiply the 9.8 times the 3.7 and then the 10 to the 4th by the 10 to the 6th. Then combine our results. 9.8 times 3.7 gives us 36.26, and 10 to the 4th times 10 to the 6th gives us 10 to the 10th, using our product of powers property to add those exponents. This is great, but be careful, it's not yet in scientific notation because 36.26 is not a number between 1 and 10. So we need to move the decimal between the 3 and the 6, which is one more 10 to the left. So that means our power of 10 increases by 1 to 10 to the 11th. Now this is in scientific notation, 3.626 times 10 to the 11th. This example involves division. Once again, we consider the two parts separately to make this easier. When we divide 1.9 by 7.6, we get 0.25. When we divide 10 to the 12th by 10 to the negative 6th, we get 10 to the 18th. Recall that when you divide with powers with like bases, you subtract the exponents. In this case, 12 minus negative 6 gives you 10 to the 18th. Again, we need to be careful because 0.25 does not meet our criteria of a number between 1 and 10. So we convert 0.25 to 2.5 times 10 to the negative 1. Then we combine that with the 10 to the 18th, and we get 2.5 times 10 to the 17th as our final answer in scientific notation. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, first question is, what are we trying to do here? What we're trying to do is write this number in scientific notation. How do we do that? We have to get a number between 1 and 10, so we move the decimal point between the 7 and the 5. When we do that, we're moving it 7 places to the left, or think of it as the 10 millions place. So we get 7.5 times 10 to the 7th. That's in scientific notation. Let's try another one. In this case, we're given it in scientific notation, and we want to write it in standard form. So what do? We simply move the decimal point 5 places to the right, or think about 10 to the 5th as the 100,000ths place. So then our answer is going to be 386,000. That's standard form for this number originally written in scientific notation. What about this one? What do we do first? We place the decimal point between the 4 and the 2, which means we moved it 5 places to the right. So our answer is 4.2 times 10 to the negative 5th. Any number that is less than 1 is going to have a negative exponent for the 10. Any number bigger than 10 is going to have a positive exponent. Let's try another one. What's different about this one? This one involves a product of two numbers in scientific notation. What do we do first? We group the C part together and the powers of 10 part together to make this easier. What's next? We multiply the 2.4 by the 5.1 to get 12.24, and the powers of 10 together to get 10 to the 5th. Are we finished? No, because 12.24 is not a number between 1 and 10, so we need to move the decimal one more place to get 1.224, which gives us one more 10. So we get 10 times 10 to the 6th. So in scientific notation, our final answer is 1.224 times 10 to the 6th. What do we do first on this one? Group the C part together and the powers of 10 part together. Now what? Now we divide the 2.3 by the 4.6 to get 0.5, and we subtract the exponents on the powers of 10 to get 10 to the 4th, because negative 6 minus a negative 10 gives us a positive 4. Are we done? No, we need to write 0.5 as a number between 1 and 10, so we need to write it as 5.0. This requires us to move the decimal one place to the left, so we need to borrow a 10 from that 10 to the 4th, which leaves us with 5 times 10 to the 3rd, or 5,000. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. Let's try one more. Same thing. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here is the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn the definition of scientific notation and how to read and write numbers in scientific notation. We did that by learning the form of scientific notation is C times 10 to the n, where C is between 1 and 10, and n is an integer. We can figure out how to write it by counting the number of places we need to move the decimal, in which direction we move it, which determines whether it's a positive or negative exponent, or by thinking about place value.